So we're going to be looking specifically at complementary angles, supplementary angles, and then the word perpendicular, okay? So the first definition we have is complementary angles. And by definition, it says two angles that add up to 90. So here we see that angle 1 and angle 2 are complementary angles. How do I know that these two angles add up to 90? What's there? That right angle, that 90-degree box. So sometimes look for the box and see if it's there. And if it's there, then they're 90 degrees. Now, they're not telling you they're equal. They're just saying that angle 1 and angle 2 add up to 90 if there's a right angle. Now, complementary angles don't have to be next to each other, or they don't have to be adjacent. They just have to add up to 90. So 65 plus 25, does that add up to 90? Yes. So 65 plus 25 equals 90. That means they are complementary. Okay? So you'll have some questions that just ask that. So you have to look at the word and then look on your notes and read what that word means. It says, given that angle 1 is the complement of 2 and angle 1 is 17, what should angle 2 be? Well, we just said that complement means what? A right angle or 90 degrees. So if angle 1 plus angle 2 equals 90, and we already know angle 1 is what? 17, I'm going to look for angle 2. So what should I do with the 90 and the 17? Subtract it. Can someone give me 90 minus 17? What is it? 73 degrees. And that's going to be angle 2. Okay, let's try the same thing with practice 1. So I'm going to give you a second to try that practice 1. Okay, so if we're doing the same thing, what am I going to do to figure out angle 1? X plus 8 equals 90. So what is X equal to? 82 degrees. Good. All right, so that's complementary. Supplementary. They're spelled almost similar for the exception of that first piece, but they do have that mentary at the end, right? Complementary and then supplementary. These angles add up to 180. So how many degrees is in a straight line? Does anyone remember? 180. 180. So anytime two angles sit on there, they're not just a linear pair, but they're also supplementary. So angle 3 plus angle 4 are supplementary angles because they make a straight angle. And again, they don't have to be next to each other. They can be separate. 60 plus 120 equals 180. Okay, so same thing. We're just looking at the word supplementary. Given that angle 3 is a supplement of 4 and angle 3 is 119, let's figure out angle A. So because they're supplementary, you need to remember that that means they add up to 180. So I'm already giving you one angle. What is 180 minus 119? 61. So the measurement of angle 4 is 61 degrees. And that's it. It's just a subtraction. The measurement, that's an M. The measurement of angle 1 is 61 degrees. All right, so I'm going to give you a moment to figure out practice 2. All right, so we would do 180 minus 117, and what did y'all get? 63 degrees, and that's your answer. All right, last vocabulary word we're looking at is called perpendicular lines. And these lines, when they intersect, they form exactly 4 right angles. Obviously, if they're all the same, they're considered congruent, okay? So with that said, if there is a 90 degrees on one side, there should be 190 degrees across from it, right? Because that's vertical. And remember, two angles, when they sit on the line, they should add up to 180. So if this is 90, the one next to it should also be 90, and the one across from that should also be 90. So anytime we have two lines that cross, there's exactly 490 degrees created in there. Now the notation, this is how you're going to see it. It's going to read line A to D is perpendicular to line C to B. So this little symbol right here, that means perpendicular. That means when you see that, you're allowed to add a 90 degrees. And I say that today because in one of my other classes, students saw two lines crossing and they go, Miss, that's 90, right? And I said, well, is there a 90-degree box there? And he's like, no. Like, did I tell you they were perpendicular? Nope. Then you can't assume it. You can only say it's 90 if there's that box, or if I'm giving you that definition either by the symbol or by the vocabulary word. Okay? All right, complementary, supplementary, guys. Again, these two look very similar. You're going to have to remember the difference the day of their test. So this is how you can remember it. The C easily turns into a 9. That's 90 degrees. The S turns into an 8. That can easily turn into 180. And that way you distinguish the two. Those are going to be some easy questions, but if you don't remember what degrees they should be, you can also get them wrong. Okay? Let's put all this to work. So first thing we're going to practice is looking for that 90-degree box. So here I have find the value of x and angle BCD. So you're going to look for two things. Find x and find angle DCB. So that C to D is perpendicular to C to A. So they're just telling you that C to D makes the 90 degrees with C to A. And that 90 degrees is already there. So does each angle equal 90? No. Do the angles equal each other? No. The two angles together add up to 90, okay? So we're going to add them together. We're going to say 3x plus 9 plus 2x minus 4 is going to equal 90. What are my like terms here? 3x and 2x. How many x's is that? 5x. All right, now let's do the other ones. We have a positive 9 and a negative 4. Plus 5 equals 90. Let's subtract the 5. 85. And what's our last step? Divide it by 5. X is equal to 13? Oh, 17? All right, we found the first part. We found x. So you always read the question. For you guys, that answer box kind of reminds you of what we're looking for. So now they're asking for angle DCB. If you trace DCB, they're specifically looking for this angle. So you have to use that equation. This is first step. Second step, we're going to take 3x plus 9, and we're going to plug in our x. What did we say our x was? 17. So 3 times 17 plus 9. What's 3 times 17? 51 plus 9? 60 degrees. And this is going to be the measurement of angle DCB. All right, I'm going to see if you can do one on your own, okay? So see if you can do that bottom one. The only difference between the one we did and the one you're doing on your own is that you have to read the formulas. Now, for some of you, it's important to add the formulas to the diagram. So between letters A, B, and E, we're going to put 4x minus 8. And between E, B, D, we're going to put 2x plus 2. Now, we just said that if there's a 90 degrees here, there should also be one across from it. So there should be a 90 degrees here as well. So together, they should add up to 90. So when I combine like terms, what do I get? What else? Minus 6 equals 90. After I add the 6, we get 96. And then when I divide by 6, we get 16. And this one just asked for x. So we're done with that one. Okay? Looking at the next one, same thing where we're going to have to enter our own formulas. So in between the letters E, B, and F, I'm going to write 6x plus 5. And between F, B, and C, I'm going to enter 4x minus 5. Bless you. I tell you that E to B, or B to E, and B to C, I tell you that it's perpendicular by that symbol. That means that you can add the 90 degrees. So just like the last one, we're going to add those together. And we're going to set it equal to 90. So combining like terms, 6x plus 4x is how many x's? 10x. What is positive 5 minus 5? 0. So this should just equal 90. Divide by 10. X is equal to 9, and that meant, I think that was meant to be an X there. Okay, and then the last piece, I'm asking you specifically to find FBC. So that means we have to use that formula, the one right there in between letters F, B, and C. So step 1, step 2. 4x minus 5, our x we said was 9. So what's 4 times 9? 36 minus 5? 31. And that's the measurement of angle FBC. Okay. When you're ready, we'll go over the back side and we're almost done. So you have that right side, I believe, to work on. Like there's a bunch of, right? Or is it one full page? Is it one full page? Yeah, on the back side? Okay. So then you guys have a lot of room back there. All right. So this one. Oh, given that NSP, it says given that NSP is 10x, NSP is 10x, and PSQ is 5x, find the value of x and y. So if there's a 90 degrees here, should there be one next to it? Yes. So I'm going to say 10x plus 5x equals 90. What's 10x plus 5x? 15x. Divide that by 15 for me, and what do we get? 6. Yes. All right, we found x. Now we have to find y, okay? So if there's a 90 degrees here, should there be one next to it down here? Yes, because remember, anytime two lines cross, technically there's 4. So for this one, I'm just going to write 15y plus 30 equals 90. Let's subtract the 30. 90 minus 30 is 60. And if we can divide that by 15, what do we get? 5? 4? 4. All right, we got the y. And that was all they wanted you to find. Okay? All right, so just keep in mind, again, that if there's a 90 degrees, there's always one next to it when two lines intersect, okay? Now, the last thing we're going to talk about is what we can assume and not assume. So again, in this class, we just can't assume whatever we want. So just because it looks like a square, we're not going to say it's a square, okay? So you need justification on what we have. So here, things you can assume. We can say that all the points are coplanar, that they're all on the same plane. We can say that points G, H, and J are collinear because they sit on the same line. We can say H and M, H and L, H and K, and line G to H all intersect at point H. We can say H is between G and J. We can say angle GHM and MHL are adjacent, that they're next to each other now. And the other ones apply too, but let's talk about what we cannot say. We cannot say that H to M, that this line, and H to L, which is this line, we cannot assume that that's 90 degrees right there. Even if it looks remotely to be 90, it cannot be 90. Even this one here, if I said H to G and H to L is 90, it may look it, but unless there's a box there or a vocabulary word was given, guys, we cannot assume it. Okay? So let's practice on deciding on what we can assume, because Renee's falling asleep on me back there. Determine whether each statement can be assumed from the figure. If so, explain. We're just going to put true or false. Do you think we can say that angle DBC is complementary to angle ABG? What does complementary mean? Complementary? It makes a right angle. Do you think I can say those two angles make a 90 degrees? No. So this is false. We cannot assume this unless more information was given. Okay, let's go to the next one. Do you think I can say that angle ABD, and let me trace that one, ABD, can we say ABD and CBD, can we say these two are supplementary? Yeah, they're sitting on a line. A line's always 180. That one is true. Okay, let's go to the next one. Do you think we can say B to F and B to G are perpendicular? What does perpendicular mean? That they make what degrees? 90. Can I say those two rays make a 90 degrees? Yes, there's a box right here telling you that it's 90. So yes, this one is true. Okay, let's look at the next one. How about, what can I say, what can be said about angle GBF? What can I say about that angle? That it is exactly 90. I can say that the measurement of angle GBF is exactly 90 degrees. And then the last one. Do you think I can say ABG is adjacent, and that's the vocabulary word from yesterday. Can I say it's adjacent to CBD? Can I say these two are next to each other? The red one and the blue one. Remember yesterday we talked about that being like your neighbor. Are these two right next to each other? No, so this one's false. Good.